Today in class, we're going to spend some time reviewing linear equations and the three forms that we've talked about this school year. So if you open up your note packet that I handed out to you and you head to the very end of the packet, you'll notice that I originally had notes for the topic of just standard form. But I've adjusted some things since I made this packet, and instead of just focusing our attention on standard form, I decided to talk about all three forms of a linear equation, just for good review. So today we're going to talk about slope-intercept form, point-slope form, and standard form. So you're welcome to use your note packet, but I did modify quite a bit. So you might just want to take out a sheet of paper and take some notes on these specific topics we're going to be looking at. Okay, and feel free to pause the video whenever you need to. So these are the three forms of a linear equation that we've talked about this year. We've talked about slope-intercept form, where we have that formula y equals mx plus b. And the m represents the slope and the b represents the y-intercept. We've also talked about point-slope form, where the m is still the slope, but this time part of the formula is x1 and y1, and that represents a point on the line. And then the last form that we talked about is standard form, and the formula is ax plus by equals c. And if you remember, there are a couple stipulations that have to be in place for an equation to be written properly in standard form. And that means that the a, the b, and the c must be integers, so they cannot be fractions. And the a coefficient has to be a positive number. So let's go ahead and take a look at all three of these. And I just have 4 problems, but I'm going to be approaching them in multiple different ways. Okay? So none of this should seem new to you, but instead it should just kind of be a nice little review of this information. Okay, let's look at this first one. It says, write the equation of a line in slope-intercept form, point-slope form, and standard form. So we're looking at all three forms. So probably the easiest and the one that kind of comes to our mind first is slope-intercept form. So let's look at this line and go ahead and write this in slope-intercept form. We know that with slope-intercept form, we always find the y-intercept first. And we can see that our y-intercept is at positive 1. And it looks like we have to find another point for our slope. So I see that this is a nice point at a cross section. And that would give us a slope of 2/3. So to write this in slope-intercept form, we would have y is equal to 2/3 times x plus 1. That's usually the easiest way to write an equation of a line. But we can also write it in other forms. So this was our slope-intercept form. So now let's go ahead and write it in point-slope form. Now the cool thing about point-slope form is that you can actually write the equation using any point on the line. And I'm going to kind of show you what I mean by that. Any point on the line, I'm just going to go ahead and pick some nice points. This is a nice point, this is a nice point, this is a nice point. And I'm going to go ahead and just label them to just kind of show you how to do this. We have -3, -1, that's one of my points. This one is 0, 1. And then this one up here is 3, 3. So with point-slope form, you can use any of those 3 points to put into the formula. So the formula, I'm just going to go ahead and write it here. It's y minus y1 equals m times x minus x1. We know that the m represents our slope, and we already know that the slope is 2/3, so we're going to write that in. But now we're going to write the actual point. And the point is going to come into play right here with the y1 and the x1. So let's go ahead and I think I'm going to start with this point here, this one right up here. I see that my x value is 3 and my y value is 3. So I'm going to go write that in here as y minus 3 is equal to my slope times x minus my y coordinate of 3. And that is how I would write the equation in point-slope form. I could also write this like this. I could also write it using this coordinate here. And that would look like this. Y minus my y coordinate, which is 1, equals my slope, which is 2/3, times x minus 0, which is my x coordinate. I could also write it using this other coordinate. Perfectly fine to do this. So y, now this is a little weird because look at the y coordinate. Do you see how it's negative? Since my formula has a minus sign in it and the coordinate has a negative, it's actually one of those double negatives, negative, negative, giving me +1. It's going to be equal to the same slope times x, and that double negative rule is going to apply here as well, where I'm going to say +3. So the point is here, either one of these options is the correct way to write an equation in point-slope form. All you need is a point and a slope in order to put it in this form. Okay, now we're going to go ahead and take a look at standard form, because standard form is always kind of the one that gives most people a headache. So let's look at this one. So the formula here is ax plus by equals c. And so here, a couple things we can do here. Now, you can take the equation that is in slope-intercept form, so the one way up here, or you could take any of the three that we put into point-slope form and use them in order to get to standard form. You cannot get standard form from the graph itself. So, usually, probably the easier way to do this is using your slope-intercept form. So let me show you how to do it using your slope-intercept form. And if you prefer, you can absolutely do it using your point-slope form. It doesn't matter. But we're going to go ahead and put this in the form ax plus by equals c. Now, there's a couple things you can do here. You can begin this problem by multiplying both sides by 3 to get rid of that denominator, get rid of that fraction. But I like to personally do that at the end, so I'm going to go ahead and move the x over to the left-hand side because that's how I'm going to get it in the form of that formula that I want. So now I have negative 2/3 x plus y is equal to 1. Now, we're getting closer into standard form, but we're not quite there because we have a fraction as our a coefficient, and we also have a negative. To eliminate both of those at once, we're going to multiply both sides of this equation by -3. If I multiply -3 by the first term, that leaves me with 2x. Do you see why we multiplied by the 3 and the negative? It gets rid of both of those in the same step. But don't forget, -3, we're going to multiply it by y as well. So that's going to be -3y. And we're going to set that equal to -3. And there you have it, you're in standard form. So there you have 3 different forms of a linear equation, but you have the same line because each of those equations is representing that line that you see in blue. Okay, let's try another one. Same directions here. We're going to write the equation of the line in slope-intercept form, we're going to do point-slope form, and we're going to do standard form. So let's go ahead and start. Right now, looks like we have an equation, and the equation is not in any particular form. So I say we put it into slope-intercept form because that's probably the most common form that, is familiar to people. So I'm going to go ahead and just rewrite it here. There's a couple things you can do. You can manipulate this equation to get the y on the left and the x on the right along with the constant, or you can kind of play around here. I am going to go ahead and try to get y on one side and everything else on the other side. So watch what I'm going to do here. I'm going to go ahead and add 10 to both sides. I know it might look backwards, but that's okay. Now, at this point, if it bothers you that the y is on the right-hand side, you can absolutely turn it around to make it look like this. You're just manipulating the equation. To get the y by itself, we have to divide both sides by 2. So I'm going to go ahead and do that. The 2's here cancel out. Y is going to equal, well, we got to do that little butterfly thing that we've done in the past. So that's going to be 1/2 x, so I have a slope of 1/2. And then positive 10 divided by 2 is positive 5. And there you have slope-intercept form. Now, let's go ahead to point-slope form. Point-slope form is a little trickier because you got to do a little bit of thinking here. You have to ask yourself, do I have a point and a slope? And I do, it's just kind of hidden. I obviously have a slope of 1/2, but the point is the part that's a little bit harder to see. The point is actually positive 5. It's the y-intercept. We know that this coordinate as a y-intercept is going to be at the point 0, 5. So using that information that our slope is 1/2 and our point is 0, 5, let's go ahead and put it into the formula. Y minus 5 equals 1/2 times x minus 0. And there you have it. Now, we want to put this equation into standard form. And again, you can use your slope-intercept form, your point-slope form to go straight into standard form. Or you know what else you can do with this one? You can actually even use the original equation to transfer it into standard form. So you have 3 options here to do truly whatever you'd like. So I think what I'm going to do just to get the extra practice is I'm going to transfer my point slope form into my standard form. So I'm going to go ahead and begin with my point slope form here. And I'm going to go ahead and start this problem off by distributing this slope. So y minus 5 equals 1/2 x. Now, I need to get my x on the left and I need to get my constant on the right. So I'll go ahead and start with the constant. I'm going to go ahead and move 5 to the right side. And then this is where I can either multiply both sides by 2 or I can subtract the x. I always like to subtract the x value. I just find it to be easier. All right. And the last step is to eliminate the -2. Now, it's not always going to end up like this, but in this case, it did. So if you didn't have a negative in front of there, you would just multiply the equation by 2. And if you just had a fraction, you would just eliminate that number in the denominator by multiplying both sides by that number. But in this example, we're going to go ahead and multiply both sides by -2. And when I distribute it in, that's going to leave me with plain old x, 1x, -2y, and that's going to equal to -10. And there's your standard form. See how we're just transferring between the 3 forms? They all mean the same thing. They're all going to be, they're all going to construct the same line, but they're just written differently. Okay, I've got a couple more things to look at. Now, I love this problem because this one's always, a little bit more challenging. This time we have the same directions, but we know that the line is going to pass through these 2 points, 2, 5, and 1, -5. And one thing I don't want you to do is pull out a sheet of graph paper and plot these and try to find the line. That takes way too much time. It's better to use a procedure to figure this out. So let's talk about slope-intercept form first. So slope-intercept form, we obviously need a slope and we need a y-intercept. Okay, so let's go ahead. I'm just going to write my slope-intercept form here. So y equals mx plus b. And to determine my slope, I have to use my slope formula. And remember how we used to always label this x1, y1, x2, y2? Because I need to put it into my slope formula. I'll go ahead and write down my slope formula here. m equals y2 minus y1 over x2 minus x1. All right, so here's my slope. Negative 5 minus 5 divided by 1 minus 2. So I'm just going to go ahead and simplify that down to negative 10 over negative 1, which gives me a nice even slope of 10. Okay, now that I've got my slope, I need to figure out what the y-intercept is. And in order to do that, we're going to plug in our slope and one of the points from up above into this formula for slope-intercept form. Now, you can pick any of those points that you want. I usually like to pick the point that doesn't have any negatives in it if I have an option. So I'm going to go ahead and use this point right here. So I'm going to go ahead and put a 5 in for the y. My slope is 10. My x is 2. And then I don't know what the y-intercept is here. So that's why I'm going to solve for it. So let's go ahead and solve for it. 5 equals 20 plus b, and I'm going to subtract 20 from both sides, giving me b is equal to negative 15. So now that I have a slope and I have a y-intercept, then I have an equation. So my equation is y equals 10x minus 15. And that's my slope-intercept form. Now, I can move to point-slope form, or I can move to standard form. It doesn't matter. I'm going to go ahead and just kind of stick with the kind of the pattern that I've been doing. So I'm going to go ahead and put it into point-slope form. And point-slope form is great because we already have used the slope formula to determine the slope, right? Because we need a slope and we need a point. So our slope we already calculated, which is 10. Now what's great here is you can choose either point to use, and I'm actually going to show you both. So I'm first going to use the point 2, 5, and I'm going to plug that right into my formula. Y minus 5 equals 10 times x minus 2. And there you have it. There's one way you could write this in point-slope form. And I could also write it using the other point. It really doesn't matter. It's the same line. I usually just like to at least do one of them. So that's going to be y. And look at my y value here, right? This is x, this is y. It's a negative 5. So that's going to change it to a positive 5 because of the double negative. Equals 10 times x minus 1. And there we have it. So there's your point-slope form. And now for the last one, standard form, again, you can go and use your slope-intercept or your point-slope form to get to your standard form. But you have to use one of them. There's no other way to do that. There's no other way to really go to slope-intercept form. So let's go ahead and let's look at, I'm sorry, I said slope-intercept form, I meant standard form. But let's go ahead and use our equation for slope-intercept form and put it into standard. I think it's a little bit less work to do using this formula. So I'm going to go ahead and I'm going to subtract 10x from both sides to get my x on the left. And I have negative 10x plus y is equal to negative 15. Now notice that my a coefficient is a negative number. In order to eliminate it, I'm going to multiply both sides by negative 1. Do you see that? Multiply it by negative 1. That's going to leave me with 10x and negative y. And that's going to be equal to positive 15. And there's your standard form. The last example is my favorite. Same question here, but we're given a line that looks like this. And when you're given a line that looks like this, we remember that the way that we write this line in all three, slope-intercept, point-slope, and standard form is the same. So we're going to write it as x equals 3. And that's it. So if the question asks you, how do you write this in point-slope form? That's it. How do you write this in standard form? That's it. How do you write this in slope-intercept form? That's it. You're done. And just as a little refresher for you, just to kind of remember the difference between vertical and horizontal lines, this is the way that I remember it. When you have a little X like this, there's all these little V's in the letter X, and V is for vertical. So if you have any equation that's X equals something, it's a vertical line. And likewise, if I were to have a horizontal line, it would end up being something like Y equals 3. And the way I remember it is, if I take a Y and I turn it upside down, it kind of looks like an H for horizontal. But whether it's an X equals or Y equals equation, that is the way that you write it in all three forms of a linear equation. Okay, that was a little review of linear equations. Now what I'd like you to do is try the class activity that's going to pull this all together. It's really important to make sure that you leave Algebra 1 with a really solid, firm understanding of linear equations.